This video is the first for the Stsd Statistics and Standard Deviation module, and we're looking at sections A and B. So to begin, let's look at the objectives of the module. Firstly, to calculate the mean and standard deviation of list, tables and group data, to determine the correlation coefficient, to calculate z-scores, to use normal distributions to determine proportions and values, to use Chebyshev's theorem, to determine correlation between sets of data, to construct scatter plots and lines of best fit, and to calculate correlation coefficient and regression equation for data sets. So firstly, let's start with calculating the mean. Now the mean is a measure of central tendency. It is a value usually described as the average. The mean of a population of n values or scores is defined as the sum of all the scores of the population, which we can write like this, the sum of x, divided by the number of scores n. So a population mean is represented by the Greek letter mu, and we can calculate the mean as follows: mu equals the sum of x all over n. Now that was a population mean. If we're looking at the sample mean, now what that means is often it's not possible to obtain data from an entire population. So possible reasons may be it costs too much, or it's logistically impossible to obtain data from the population. So in such cases we get a sample of the population. Now the mean of the sample of n items drawn from the population is defined in the same way, but we denote it as x bar. And you can see the formula here. So the only difference is we're using x bar rather than mu. So let's look at an example. This example says calculate the mean of the following student test results percentages. We have a number of percentages there. So the mean, obviously it's not a population, we just have a group of data. So it's the sum of x over n. So we're going to have to add all these numbers up. So 92 plus 66 plus 99, you get the idea, plus 69, all over how many there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If you add all those up, you get 784. It's divided by 11, and our answer is 71.27. The 27's recurring. So the mean of student test results is 71.27%. Now let's look at calculating the mean from a frequency distribution table. Now when calculating the mean from a frequency distribution table, it's necessary to multiply each score by its frequency and sum these values. This result is then divided by the sum of frequencies. Now note this module follows on from TM1, okay, Transition Mathematics 1, and we did have a statistics module in TM1, so if you're finding this starting at a too high level, you might want to go back to that. So the formula for the mean for a frequency table is the sum of fx all over the sum of f. Calculations using this formula are often simplified by setting up a table as shown in the next example. So here it's got calculate the mean of numbers, or mean number of pins knocked down from the frequency table. So in order to do this, I need to work out what fx is. So that's just 0 times 2 is 0, 1 times 1 is 1, 2 times 2 is 4, 3 times 0 is 0. So you can see that I've filled in the rest of those. We also need to sum up our frequencies, and if you add up all these numbers you get 60, and then sum up our fx column, which is 420. So the mean is given by the sum of our fx all over the sum of f. So that's 420 divided by 60, which is 7. Finish with a therefore statement. Therefore, the mean number of pins knocked down was 7. Calculate the mean for group data. Again, we're going pretty quickly through this because it is a TM1 module. All of this was covered in TM1. Now, if the frequency distribution table has group data, or intervals, it is necessary to use the mid value of the interval in mean calculations. The mid value for an interval is calculated by adding the upper and lower boundaries and dividing the result by 2. So you're finding the mean of them, and that's shown there. So this example says calculate the mean height of students from the frequency table, and you can see we have group data. So what we need to do is find the mid value for each of those, and for this here we'd go 140 plus 145, so we round up to the start of the next one. So it's the start of the first one at the start of the next one, and we divide by 2, and you would get 142.5. So for the next one it would be 145 plus 150 divided by 2, which would give you 147.5. Now we already have our frequencies here, so what we need to do now is multiply our mid value x by our frequency. So this would be 1 times 142.5, which is 142.5. This would be 1 times 147.5, which is 147.5. Then we have 2 times 152.5, which gives me 305. So we keep going down multiplying f by x. So you can see that I've gone through and filled those in. We now need to find the sum of our frequency column. So if you add up all these values you get 20, and then the sum of our fx column. So if you add up all these values you get 3,215. From there our mean is the sum of f of x over the sum of f, so that's 3215 divided by 20, which gives us 160.75 centimetres. So you would say therefore mean height was 160.75 centimetres. What now? Practice exercise Stsd B1.